Chapter 1, Section 10. Complete your warm-up. The objective for this lesson is to learn to write and graph an inequality from a word problem. The essential question, what are the steps to solving an inequality problem? Some vocabulary terms we'll use: inequality, algebraic inequality, and solution set. An inequality compares two quantities and typically uses one of these symbols: less than, greater than, less than or equal to, greater than or equal to. Remember, the inequality symbol opens to the side with the greater number. So when it's pointing to the left, we would say 2 is less than 10. Let's start by comparing. In these examples, what we need to do first is make sure both sides are down to a single number. So in example A, we would start by subtracting 23 minus 14 to get the number 9, and then compare 9 to 6. We would say 9 is greater than 6. Example B, take 5 times 12 to get 60, and comparing 60 to 70, we would say 60 is less than 70. An inequality that contains one or more variables is an algebraic inequality. And a number that makes an inequality true is a solution of the inequality. What's different about inequalities versus equations, in equations you have one number that is the answer. For inequalities, it's a set of numbers. So we call that set the solution set. We can show that by graphing it on a number line. When we graph an inequality, we have two types of circles. An open circle means that the corresponding value is not a solution. A solid circle means that the value is part of the solution set. Looking at the example on your notes, you have the expression W is less than 5. In words, it would look like that. The inequality that you see is W is less than 5 with the symbol. Some sample solutions mean what are some numbers that you could choose for W that would make this true. So W could be 4 because 4 is less than 5. W could be 2.1 because 2.1 is less than 5. We could go on and on and on forever. So our solution set starts at the number 5, but we use an open circle. Because W is less than 5, we have to start at 5 since everything to the left of that would be less than. But we can't include that. So we use an open circle to show that we're starting at 5 but not including. And then the less than numbers are to the left. And we use an arrow because the arrow shows that the numbers go on forever. Let's look at another one. Y is less than or equal to 2. And another way to say that same phrase, Y is at most 2. So that would look like the less than or equal to symbol. Some solutions could be 0, 1.5. We could go on and on. We could pick any negative number. For this solution set, you'll notice that our circle is solid or colored in because we have the equal to part. So it can equal to, but it also can be less than. Most inequalities can be solved the same way equations are solved. We use inverse operations on both sides of the inequality to isolate the variable. Remember, in graphing an inequality, open circle means the value is not a solution. Solid circle means the value is part of the solution. So think about it. Which symbols represent open and which represent closed? Open, less than and greater than. Closed, less than or equal to, greater than or equal to. It's as simple as remembering that if you see the equal to portion, it's a closed circle. If you don't, it's open. Solve and graph the inequality. W minus 1 is less than 8. We solve this exactly like we would if it was an equation, at least to start. So we see W is the variable, and right now we are subtracting 1 from it. So the inverse operation would be to add 1 to both sides. Again, just like a scale, we keep it balanced. Our 1's cancel, so we have W is less than 9. What's different about an inequality is we now graph our answer. So we make a number line that 9 is near the middle or in the middle. Because we see the less than symbol, we use an open circle at 9. And then pick some numbers to try and make sure you're going the right direction with your arrow. For example, if I chose the number 7, 7 is less than 9, so I want to make sure my arrow points towards that number. Let's try another one. X plus 2 is greater than or equal to 3.5. Subtract 2 from both sides. X is greater than or equal to 1.5. Graph it on my number line. 1.5 would be between 1 and 2. And this time it's a closed circle because we have the equal to, and greater than would be to the right. Okay, example B. We have the variable u that's being multiplied by 6. So our proper step would be to divide both sides by 6. U is greater than 12. Open circle at the number 12. Arrow to the right. What if we want to work backwards? Write the inequality represented for each example below. Here's our first example. Look at the pieces. First of all, we see that it starts at the number 0. So we know that we are comparing a variable to 0. Let's just choose a variable. Let's say we choose x. Now we have to decide if the arrow is pointing to the right, that means that the values are greater than 0. And when we look at the circle, we see it's closed. That means that we can equal 0. So if we double check, x is greater than or equal to 0. If I pick 1, 2, 3, any of those numbers and plug it in, it works. Let's try the next one. Okay, again, we need to pick a variable. Let's use n this time. And then I see the number 3 is where we have our circle. So the arrow's pointing to the left. That means that those values are less than 3. And because it's an open circle, I leave it with no equal sign. Last example that's in your notes. Solve and graph your answer. X plus 2 is greater than or equal to negative 3. So we see the variable is x. On the same side as x, we have plus 2. So our inverse operation is to subtract 2. Whenever I do an operation to an equation or inequality, I do it to both sides. So I would subtract 2 as well on the negative 3 side. Positive 2 and a negative 2 cancel. So I have x greater than or equal to negative 3 minus 2. Picture your number line. If you're at negative 3 and you're subtracting 2, you're going 2 more to the left. That would put you at negative 5. So our graph. Well, we know we're going to be at negative 5, and the circle that we want is colored in. And that's because we have this, the equal to part. Now x is greater. So I need to pick a number here. So let's go into the positives. I like positive numbers. Let's pick the number 4. Would we say that 4 is greater than or equal to negative 5? Yes, positive numbers are going to be greater than negatives. So what does that mean? That means that since a number to the right worked, all the numbers to the right are going to work. So we would draw our line with our arrow pointing to the right. A couple expectations on your number lines. You don't need to write a bunch of values. You need to have the value that you'll be starting at with 2 numbers on each side of it. So you should have a minimum of 5 numbers listed on your number line. Make sure it's obvious if your circle is open or closed. And go ahead and draw the arrow line above your number line, not right on top of it, so that it's easier to see it. Let's wrap this up. Make sure your Cornell notes are filled out completely. Review your notes and complete the summary before class. Come prepared to take a lesson quiz on how well you understood the material. And just remember all of the steps it takes as you're solving inequalities. Good luck.